Wannie. So we'll introduce you to your speakers for today. We've got Wannie Park and Gabrielle Pincelli. So Wannie is responsible for partnerships and business development at Bidgely. He has a 20+ year track record of scaling growth at venture-backed clean tech companies. Prior to joining Bidgely, Wannie was CEO of Zen Ecosystems and VP of Corporate Development at Inspire Clean Energy, helping lead the successful exits of both companies. He earned his law degree in environmental law at UCLA and his MBA at USC. In his free time, Wannie's an avid surfer, snowboarder, and fisherman, which he experiences with his 3 sons. And Gabrielle heads Bidgely's product management team. Gab has 20+ years of experience delivering software solutions and products in the energy industry, from concept to design to delivery. Gab's experience ranges across the whole energy value chain, from generation, trading, risk management, and grid optimization to retail pricing, billing, and consumer engagement, having been co-founder of Energia, a former software company providing solutions for major utilities across Europe and North America. Gab has a major degree in computer science at University of Milan. So with that, I will hand it over to you, Gab.
Yeah, hi everyone. Nice to have you. So today we're going to talk about disaggregation, energy disaggregation, which is certainly not a new topic for many of you, but we're going to discuss how we can leverage the capabilities that Bidgely has developed over the years in very specific ways and across different use cases. So we're going to first start with a quick reminder or sort of refresher of what is load disaggregation. We'll start from the next slide by recapping the concept of when we talk about non-invasive or non-intrusive load disaggregation, we're actually talking about the ability to take a single usage load, from a specific premise or home, and actually introduce a number of algorithms that have the ability to disaggregate or to disassemble that load into the load of different types of appliances or appliance categories, right? With the use of machine learning models, which means it's not about statistics, it's not about rule-based logic, but it's actually about recognizing specific fingerprints of different appliance types, and actually using those and using the machine learning concepts to actually derive the specifics of what is actually using energy inside the home in terms of appliances, what is plugged in at a certain moment in time, what gets turned on at different moments of the day. Bidgely has developed over the years this technology and has made it, very, very sophisticated. We have 17 patents, that sort of define that sort of leadership in this type of science. And of course, the whole value of this is also related to the fact that there is no hardware requirements, right? We don't need to install any device in the home or in the premise to actually detect these different types of appliances, and it works for different types of AMI meters. It works for meters with 15-minute granularity, 30 minutes, 60 minutes. So it can pretty much work across all different types of AMI technologies. So just to get a little bit more in depth about disaggregation, what you see on the left is what we typically use to train our models and actually presenting heat maps, that represent how much load is actually used for every single interval, 15-minute interval or 60-minute interval of every day of the year, of 1 year. And this is what our algorithms use to learn, again, the patterns of the customer, to detect the different types of appliances. And it's not only about detecting appliances and, identifying them. It's also about estimating them, and it's about also deriving other very important attributes of information about these appliances. If you click further, we can see, what are the items of information that we can actually derive. Now, we can derive when the appliances are used, whether an appliance is becoming inefficient, We can also derive some lifestyle information about the customer, depending on what appliances are being used in the home at different moments of the day. We can identify vacation patterns, or when it's only certain appliances are being used for long periods. And of course, what you see here on the right is the list of categories that we detect with the true disaggregation technology and the level of accuracies we have reached, which is very, very significant over time. And this is what makes our technology reliable to the extent that we can start using it, and we have been starting to use it, heavily in both the customer-facing solutions and analytic solutions, so solutions internal to the utility. We have a few more examples of capabilities, just to, again, complete the description of the power of true disaggregation. If you go to the next slide. Here's an example of how we can detect electric vehicle charging from a home load. So we can see on the left the initial input of usage, across 1 year, where we can pretty easily, from a bird's eye view, spot, what could potentially be EV charge sessions, right? Of course, because EVs have very high amplitudes, in terms of charging. We can also detect other information, such as, not only when a charge happened, but also what type of charger is being used. Is it an L2 charger, an L1 charger? When did each session for charging started and stopped? Which means we can also learn, how often or frequently the customer is charging in peak hours, with a very, very high degree of accuracy, versus when he is charging overnight. So this is very, very relevant information, again, without the need to install anything and without actually the need to directly connect, right, to any device as such. Moving on to another example. This is an example related to how we can detect different types of inefficiencies for HVAC systems, right? Here you see, starting from the left, an example of an HVAC example where we can notice after several seasons of usage that the appliance is starting to degrade over time, where the use of the appliance, also correlated to weather, of course, starts intensifying more and more, right, over the years. So historically, we create sort of a buildup of intensified usage, right? We can see, for example, when an air conditioning system becomes more and more saturated, and that period of saturation, which means the highest level of usage of a specific appliance, becomes wider and wider, right? And which means that the AC is being put under more and more stress, and it's likely to degrade more rapidly. We can see examples of short cycling, for example, when the system is not able to accomplish a full cycle before it gets interrupted and restarts again, right? We can see, for example, different behaviors of air conditioners depending on whether they are being managed by a smart thermostat or not. You can see in the two examples on the right, one where the smart thermostat is actually optimizing the energy used by the air conditioner by using it, with the right amount of energy without overdoing, the actual runs, versus, a situation where no smart thermostat is present, and you can see how much more energy is being used by the device to actually try and manage, let's say, the cooling with not so big efficiency. So in essence, all these things can be detected through our disaggregation, which makes, again, the value of the algorithms and the value of the data that we generate immense from that perspective. Last example before I hand it over to Wannie. If we can go to the next one. This is an example where we can see the combination of two big loads. As I mentioned before, we can also detect, as part of our algorithms, the generation of solar energy from solar panels within, again, the same analysis of that single load coming from the meter. So here we start from the left, seeing the complete usage, which at some points during the daytime even goes negative or to zero, actually, you know. But we see those overlaying lines, which actually represent potential EV charges. So what happens is disaggregation first, identifies and detects the solar generation, removes that load from the base usage, and what is left is the total consumption in the home, where it is even easier to then identify and detect the actual single EV events. So you can see that even in situations where solar panels and solar generation, one could think may hide, the use of other appliances, even big ones like EVs, our technology can actually help detect that very, very easily. So all in all these examples are meant to take to make the following point. If you go to the next slide. Normally, disaggregation has always been a technology that has mainly been based on statistical analysis, of course, so with not so much ability by companies to actually provide unique detection of single appliances. This means that the use cases that can be leveraged, that in which this data can be leveraged, are not many. You can show certainly a disaggregated consumption, but over probably monthly aggregates, right? And no more than that, because you are not able to actually expose an actual consumption at a more granular level of detail to a customer. A customer will easily complain that appliance was not used, or was not, actually he was not in the home that day. So you need to keep the data aggregated. With Bidgely's true disaggregation, it's exactly the opposite. We are definitely leveraging the technology to expose very detailed data to customers, which of course increases dramatically the number of use cases that we can actually use this technology and this data in. And speaking of the use cases, then I will leave it to Wannie to actually explain some of them.
I'm going to jump in. Pause real quick. I think on the last slide, we got a question, Gab, for you. And
Sure.
The question is the user attribute from a pad mount transformer or on a feeder?
Excuse me, can you go back to the actual slide?
Yeah, I think I think it's this one, or yeah. And the question was, is the user attribute from a pad mount transformer or on a feeder?
The user attributes, I think all the user attributes we relate to appliances that are detected within the home, or right within the premise. So there's no access to data coming, related to feeders or transformers as such. So all the attributes that we detect are related to the appliance categories that we see here. If I have interpreted the question correctly.
I think, yeah, maybe, we can talk about in terms of the DaaS journey where we ingest it at the meter level. Maybe that'll give the audience a little bit more clarification when we get there.
Okay, sure.
Cool. Michaela, good to move on?
Yep, all good, thanks.
Okay, great. Thanks, Gab. So, I think that was a fantastic background, right, in terms of Bidgely's journey in regards to building disaggregation, scaling it, all that good stuff. And I think, the purpose of this webinar is actually to kind of, provide a little bit more insight in terms of, what's next for Bidgely as well as disaggregation. And so, we have, we're talking about DaaS, right, which is disaggregation as a service. If you've worked with Bidgely in the past, you've probably worked with us in terms of using disaggregation, as Gab described it, as the foundation of a lot of different use cases, products, customer engagement tools, things like that. From our perspective, we feel at this point, disaggregation is not sort of a science experiment anymore. It's being used by many utilities globally. We probably manage over 40 million meters a day. So there's a lot of engagement, right? And I think what we've also seen here is that, disaggregation really has become a mature, feature set for utilities in regards to delivering different use cases. And so from our perspective, we realize that disaggregation and the ones that we have and that we've rolled out is incredibly valuable. And we want to basically, you see the first bullet here, democratize it, right? Get it out there in as many different flavors as possible. Get it out there to a lot of the partners that potentially would not be using it directly. So you see sort of on the right, different types of partners that, we would engage. So retailers, co-ops and munis, IOUs, which is sort of our bread and butter, grid planners, DR providers, DERMs, EV stakeholders. I would also add that, just sort of what's happening in the world today, which, really speaks to, different DERs, right? EVs, solar, ESS, things like that rolling out. The disaggregation piece is a key component in terms of, how you actually manage those assets, how you identify the assets, how you actually nudge and provide incentives to the end users. And so there's a lot of applications that we speak to. And so DaaS is really designed to kind of create a really nice platform for all of that. So the applications we'll get into through use cases and things like that. And I think the last thing too is that, this is really designed to be, a strong, inexpensive application in terms of an analytics tool that we can actually provide to our customers and partners. Okay. So a little bit in terms of, the journey and the onboarding and things like that. And I think this may reference one of the questions that we had earlier is really just how do we get started, right? What's the input? And, for us to activate any of the analytics, any of the disaggregation, we need the AMI data, right? And so there's multiple ways to kind of do that. And really what we would say is that it's really for us, the partners, responsibility for us to get access to that data. If we can get that data, and you can see sort of the frequency and the types of data, so 5, 15, 30, 60-minute interval data, we can actually do the traditional true disaggregation that Gab described and, what we typically do, over the last decade or so. In terms of once we have access to that data, we can ingest it, the Bidgely utility AI engine really kicks off, right? And this is where we actually provide the disaggregation as a service to the partner. And if you look at sort of the processing column here in the middle, the frequency, could be monthly as the default, but it could also be tied to the billing cycle. A lot of what we also expect, and this is where, the cost is, sort of that opening price point, easy to engage, easy to start. We expect the partner to also have their sort of their own tools, right? To not only ingest the DaaS, but also be able to go ahead and deliver it to their customers and their end users using their tools. And then in terms of the output, again, there is no degradation or dilution in terms of the different appliance usage categories. So all the stuff that Gab showed you before, we're sort of repeating it here, but you'll see the different usage categories, the appliances and things like that. So there's no degradation there. We would only say that like part of it would be, how do you want to scope it out? Are there specific appliances that you're targeting? Are there specific use cases you want to deliver? And, for us, really, we can, shape that for you. Okay. A little bit more details. I'm not going to read every single one of them, but this is there's no degradation in terms of what we do, but these are probably the more popular, I'd say, top of mind categories in terms of what we deliver from a disag perspective. Gab's covered a lot of this earlier. But again, I think some of the big ones obviously is heating and cooling. So you'll get all that stuff. You see some of the details there in terms of the fault detection around degradation, saturation, things like that. Jumping over to like water heaters. There's a lot of chatter around electrification. So a lot of the work we do would actually enable that in terms of, hey, your HVAC system may be a little funky. Maybe there's an opportunity to transition to a heat pump. Same thing with water heating. There's other appliances like pool pumps and things like that. A lot around DERs, right? So all the work that we're doing around EV, very fantastic in terms of segmentation, targeting, also understanding like, who a good EV customer is, right? Are they actually complying with like, the proper method in terms of when to charge off peak and things like that. So a lot of that identification and analysis comes out of DaaS. And again, there's 30 plus attributes available, so quite a few. Okay. So what we're going to do here is maybe just dive into a few use cases, just so that, gives you an idea in terms of how some customers are actually using disaggregation. And again, there's a lot of use cases, but these are some simple ones that we can walk you through. Okay. So one is, we're very well known for our home energy reports, right? This is where we do the disaggregation in terms of how customers using energy, when they're using it, the dollars applied to it, things like that. And so, within a DaaS environment, if you are licensing the analytics tool, you can basically deliver it any way you want, right? You can create the UI, you can create the actual messaging and things like that. But fundamentally, you are now able to do at a super high level of accuracy what is happening at that customer's home, right, based on appliances. So you could see a report like this. It could be a paper report. It could be a portal. It could be an app. It could be an email, whatever distribution method you'd like to use. But fundamentally, the Disag will give you this level of granularity at north of 90% accuracy. Okay. The other side of it then is like, great, we educated you, right? What are you going to do with that? And so now you now have like really targeted methodology of basically saying, well, this is what's happening. We're going to diagnose the problem or diagnose the opportunity. And here are the different things that you can do to actually mitigate that. A lot of times it's really just a cost issue, right? Why is my bill so high? What is going on? Oh yeah, you had an issue with your HVAC system, fault detection, or maybe you're using it on peak. Are there ways to mitigate that? And we can create analytics, tooling, messaging to actually help you with that. So, okay. A lot, we talked about TOU and just, still a lot of customers are not exactly clear what that means, when to charge, when not to charge. Impact is, 10x now with EVs, online and things like that. So again, Gab walked you sort of that hourly view, right, throughout the course of the year, throughout the course of the month. And so there's different methodology here in regards to how to identify what's happening, during a billing cycle, during a season, things like that. And, again, now that you can disaggregate based on the appliance side, you can see what's happening, right, and really target what's happening. So really great messaging, helps partners, drive up CSAT scores, engagement with your customers, things like that. And the intent obviously is to do the best you can, right, in terms of being on point with the TOU rates. Okay. Think a little bit more on this. This is where we actually speak to, what's happening during peak versus on peak, and what is the actual impact, right, in terms of dollars, right? Great tool for CX folks to, to be proactive, right, in regards to what's happening. Better to kind of get in front of it, in front of any potential issues, versus, getting an angry phone call. So, all right. So I think the last piece here is really, what does it mean for a partner, right? There's a couple of things, and I think really simply, sort of three sort of columns here. The onboarding for this is super simple, right? We've designed it to be super streamlined to ingest the data. You guys have it. Allow us to ingest it and do the processing. Let us be the analytics partner. So it actually can help you reduce the cost, like with your utility customers or whoever your partners are, by about 50%, right? So time to market is much faster, and then the cost to implement is a lot lower. The other side of it here is then, specific to that optimized, CX use case, a lot of stuff that we've done sort of direct to utilities that we can actually implement in terms of best practices to the partners in terms of using DaaS. So there's a lot of things that we could do there to actually drive, reduction in, inbound phone calls, customer satisfaction increases, things like that. So there's a lot of different metrics here, but that's a really good use case. The last thing I would say is that, from a partner perspective, we take sort of a white label approach. The disaggregation, the DaaS can actually be designed to be, a branded product, for the partner. And you can deliver the innovations and sort of the upside using disaggregation. The other thing about this then is also like, it'll help you drive top line, right? You can value stack solutions. You can increase sort of the, I guess, the scope in terms of any engagement by incorporating, this level of disaggregation and the additional use cases that come out of it. So it's a very strong, margin multiplier and top line revenue driver. Okay. And that's sort of it on my end. Thank you. I'll throw it back to you, Michaela.
Awesome. We have a couple more questions in the chat. So first one is, how many appliances are able to be disaggregated with the technology?
I can take that. So it was actually in one of those slides we saw before. Right now we have around 13 to 15 appliances, which depend, appliance category, as we say, depend also on the specific geography. But essentially, these are the main ones that we always detect, independent of the geography. We can see that there's around 10 here. There's a few other categories like, for example, cooking or let's say kitchenware, entertainment, right, laundry, which we also detect, but it depends, let's say, on the geography and on the conditions, on the types of appliances. So those we keep sort of separate, but we can bring in if necessary. And then, of course, I didn't mention before, we also have some high-level disaggregation from a business perspective. Of course, these are more broader types of loads, so big loads in terms of cooling and heating. And in general, we can identify operational load, which means basically detecting big loads that happen during operating hours, which means during hours in which we detect the business as running, okay, as actually being open. So this is for both residential and business. I hope this answers the question.
Perfect. And then the next question is, what kind of data is needed to run this disaggregation?
So the data we need is relatively minimal, I would say, because we need, of course, the usage data coming from the meter. That is essential. What we need to know for each, let's say, a premise or meter type, specifically is where is it located geographically, which can be either latitude or longitude, or more commonly, zip code. If you have the customer address, right? Then we take care of actually managing additional data that we use, for example, weather information, weather data that we get directly from a supplier of ours. So we use that to correlate information with the usage, directly in our algorithm. So that does not need to be provisioned. It just comes with our package. So at the minimum, usage and zip code, I would say. Of course, as we typically create more sophisticated solutions, we also, ask for additional data if available, right? So if the utility or the partner has already collected some information about appliance ownership, so then we welcome that information because it helps speeding up the training of the model. But if it's not present, it's not necessary. We can train the model simply, using usage and location.
Awesome. I think that's it for questions. So thank you so much, Wannie and Gab, for sharing your really valuable knowledge and insights. And thank you everyone who joined our webinar today. I really hope you found it valuable. And please look out for an email from us with the on-demand recording and some other follow-up materials. And if you have any other questions, we're more than happy to answer them, either via email, or we can set up some personalized demo calls and talk through specific use cases. But other than that, I hope everyone has a great day. Thanks again, Gab and Wannie.
Thank you.
See ya.